Hello everyone. Today I'm going to talk about oscillometric blood pressure measurement. My name is Denison. I'm studying biomedical engineering at Izmir University of Economics. So let's begin our topic. Our topic is introduced with what is oscillometry, how trust is automated non-invasive blood pressure monitoring, materials and methods, and conclusion. So beginning with oscillometric method is an indirect method. The oscillometric method of measuring blood pressure with an automated cuff yields valid estimates of mean pressure but questionable estimates of systolic and diastolic pressures. Existing algorithms are sensitive to differences in pulse pressure and artery stiffness. Some are closely guarded trade secrets. Accurate extraction of systolic and diastolic pressures from the envelope of the cuff pressure oscillation remains an open problem in biomedical engineering. The second type of non-invasive blood measurement strategy, the oscillometric method, also employs an occluding cuff. However, in contrast to the auscultatory method, which relies on the detection of Karatkov sounds, the oscillometric method operates by sensing the magnitude of oscillation caused by blood as it begins flowing into the limb. Typically, very faint flow oscillations begin to detect as the air pressure in the cuff coincides with systolic blood pressure. As air pressure is slowly released from the occluding cuff, the amplitude of these pulsatile oscillations increases to a point and then decreases as the blood flows to normalize the limbs. The limb normalizes. Although the oscillations with the greatest amplitude has been shown to correspond reliably with mean arterial pressure. As you can see in the figure 1, the upper trace represent the cuff pressure decreasing from the suprasystolic to suprasystolic pressure. The lower trace represent the oscillometric waveform that were derived from the cuff pressure by low pass filtering and amplifications. The oscillometric waveform appear well above the reference systolic blood pressure, and their amplitude continue to rise until mean arterial pressure is reached. So, although the oscillations with the greatest amplitude has been shown to correspond reliably with mean arterial pressure, the determinations of systolic blood pressure, which are associated with a marked increase in amplitude of oscillations, and the diastolic blood pressure, which are associated with the point at which oscillations levels are often less accurate when compared with the auscultatory measures. These are the mathematical estimations of the oscillometric blood pressure measurement device. Typically, the oscillometric method is involved with the most vital signs are now obtained with automatic techniques. Thanks to the necessity of the repetitive measurements and the caregiver's limited time. Most non-invasive blood pressure monitors use the oscillometric technique. So basically, the cuff is placed on the patient's arm, and the cuff bladder is inflated with the air until the external pressure exceeds the internal intra-arterial systolic pressure, and the arterial pressure, systolic pressure, and arterial flow past the cuff ceases. The cuff bladder pressure is slowly raised as a pressure sensor inside the cuff detects the arterial pressure pulsations as oscillations. As the cuff pressure declines, the oscillation increases in the amplitude to maximum, which represents the mean arterial pressure. The oscillation amplitude then declines until minimum. So oscillations amplitude, when the oscillations amplitude declines down to minimum, the only pressure actually measured is the pressure at the point of the maximal amplitude, which corresponds to the mean arterial. As a conclusion, oscillometric method for invasive blood pressure measurements as used in the state-of-the-art devices is attractive for the simplicity of cuff applications and the device operations. I hope you will enjoy my presentation.